So yeah, I'll start. So this is third section of what else are there other than ls and cd. And similar from the last session, I think it would be best if you can follow what I do. So we're going to start by revising variable versus string. For running anything, if you're in PNL network, you can bash /data /PNL /kcho /example data /Linux tutorial /create example. If you run this, you will have the example folder under your home directory. So I'm going to git clone data github.com kcho. There's a Linux tutorial. I'm pulling this information into temp Linux tutorial. It's going to pull information, and then I'm going to go in there, Linux tutorial, and I'm going to run bash create _example.sh. This will create this Linux tutorial in my home, and I have all the files that I need here. Then you will have something under your home called Linux tutorial. If you go in there, you will see multilines.csv and multilines2.csv. I want to show how they look like. Multilines.csv looks like this, and multilines2.csv looks like this. Okay? I want you to find the difference between these two files, multilines2. It's really difficult. And sometimes it's not just full lines, it's sometimes hundreds of lines, and you just want to pick up which lines is different between the two files. What you do is you do diff, and then multilines CSV, and multilines2 CSV. Then it will return you the line that is different between the two lines. So on the first line, on the first return, you will see what the line was in the first file and what the other line was in the second file. So you could, I don't know where it's different, but you can tell which line was different between the two files. You don't have to go through each line, but you can just run this function. Okay, so that's diff. And I know you have to download quite a lot of files, for example, from Dropbox or from websites into the Aris server. And I saw many people downloading files to your laptop first and then SCPing files into the server. But there's a way to download files directly to your server from the terminal. So let's get an example data on the website. So go to Google and search for FSL example data. Then things come up like this. If you click on FSL course data files, then you will see a page like this. So here, they are very kind to include wget command for you, but just let's copy any of the files. So let's copy the structural data. I'm going to copy that information. Let me just leave this on the screen so you can follow with me. So type wget and simply type the web address of the data that you want to download into current location. http://fsl fmrib ac uk fsl course downloads and structural tar gz. Okay. If you have all the data on Dropbox, Box, it works the same way. Okay. If you can get the data address correct, then it will run something. Yeah, I probably made a typo. Yep, you will see some sign like this. Then you don't have to go through downloading it to your laptop and uploading it back through SCP. You can just download it in your server directly. Okay, that was wget today. That's pretty simple. Let me stop this. I don't want to download all the data. But if you have any questions about wget or diff, let me know. And I think this is most useful, but most painful command to use. Say you just used wget, but here, if you see, there's a -c option. You don't know what that is. So for every command that we did together, there are a bunch of other extra options that I didn't go through with you. man for manual, it actually shows you the full manual in Linux shell. So say man wget, the command that we just used, it's going to show you the full manual page. It is pretty long. But this becomes really helpful when you want to quickly look at what kind of options do I have. For example, man tree. We just use tree like this, very simple. But if you do tree man tree, then you will see also manuals for tree, and you can see there are a bunch of options here. For example, level. Oh, level. You can give, if you just do tree, it's printing everything up to the files between anatomical data. But if I want to limit levels into two, it's only printing two levels. So you can find a lot of hidden options in different commands. It even works for ls. Even in ls, see there's a color, there's a D file. It is not just the commands itself, but there are a bunch of options. I'm sure we don't use all of them. We just use ls. But by using manual, you can find more useful commands. And whenever you get stuck with a new option, you can look for what it is without going into Chrome online to search for stuff. So let's do this again. Let's go back to variable and path thing. So let's do echo in capital letters, path. So I expected to print the letter, the string path in capital letters. Okay? But if you include $sign in front of path, it's gonna print you a completely different thing. So there are few variables that's being used by the Linux system, and path is one of them. So there are few strings that is already being used by Linux system even before you use it. If you overwrite them with something else, that may break the settings in Linux. Path is one of them. So what path represent? So say when you do ls, you can straightly use the ls function, right? You don't have to install it or anything like that. It's already there. So when you do which ls, you know your ls function, the ls function that you're running is inside /bin. How about wget? Which wget? The inside wget is on inside user local bin wget. Okay? Even though it's saved in different places, even not in your current location, you can still use this because the path variable tells where your shell should look for executable. So let's search this. Here. You can use wget from anywhere because you have this information saved in the path. Okay? This is the error that we get so many times. For example, Tuishi has been trying to use my code, and my code has been saved in my home directory on the certain directory. If she types Kevin Cho script.sh, which is in my directory, it's not going to run because the shell doesn't know where to look for your thing. Okay? So that's when she had to type piano, K-Cho, home, Kevin Cho script, full path. You can either do this or you can change your path. Path equals whatever path was, you're overriding path with the previous path, but you're adding something. That data, piano, K-Cho, home, you're adding another location that the shell should look for when you're running stuff. Okay, that's the path variable. This is gonna come up again. I'm gonna stop explaining about the path here, but this is quite a lot of error that we see when we can't find a script. Some people say it's good practice to type full address or full path of executables, but sometimes it's really comfortable just to update your path. Okay, so let's try this. If you do path, let me print my path. Okay. Now you see there's a /data/PNL Kevin Cho home edit. There's another difference. This might be confusing, but don't worry about it. So you just change the path, but it's not being saved by the system. Okay. It's changed it, but it's not being saved. So if I open new terminal and then do echo path, the Kevin home directory is missing. Okay. So even if you change it like this, it doesn't stay there forever. So when you can't find the script, when it's not working, it's a good practice to check your path. And if it's keep refreshing, going back to a missing path, you can save that information in bash chassis. I'm going to do that later. But just remember there's a path. Yep, I think that wraps up our new list of new commands today. So you can think of variable as a data container. So you can put anything in it, but string is like letters. So character A is a string where variable A is a data container. If you understand this concept, this applies to Python, this applies to MATLAB, this applies to every programming language. So once you understand that, this will be a really good base. We learned echo in the first echo A. So it's printing the letter A. Let's do A equal ABCD. Now I'm saving ABCD string into a variable. So when we define a variable, we don't put $sign in because it's empty. We are just overriding what A is. Let's do echo A. We are still printing string A, the letter A. But when we put echo $sign in front of A, we're now printing what's inside a variable, the data container. Okay, that was the cool part from the last time. And then it was a good practice to include curly brackets to separate letters from variables. Say we want to print data container A and the string A, we had to have a way to separate variable from string. We could use curly brackets. So it's printing what's saved in A and then string A. Okay? There was variable and strings. And then we dive into loop. The default structure of looping in Linux was for something, you can call something, in Kevin, Rick, Thomas. And this something becomes each variable that you give after in. So that's just basic syntax. So these are the lists that you want to loop through. And each of them will become something each run. Okay, let's try this. For something in something, you have to do, you want to do something. Let's just echo them. Make sure that you are echoing variable rather than string. All right, and done. In our first loop, we were printing something which was Kevin in the first loop, Rick in the second loop, and Thomas in the third loop. Even though it's printing all of them once, there's a slight delays between Kevin, Rick, and Thomas printing. So first loop, second loop, third loop. We also did adding strings. So do echo, I wanna say subject is something. Okay, so this time I'm printing string subject is, and then variable something, which will be Kevin in the first loop, Rick in the second loop, and Thomas in the third loop. Okay, that's what we did last time for the loop. So that was variable versus string.